So this video is going to be over the combined gas law. So we're going to start out with the formula, and it is P1 V1 over T1 equals P2 V2 over T2. The pressure equals P, V equals volume, and T is equal to the temperature, always in Kelvin. The pressure and the volume can be in anything, they just have to be the same. So we are going to start with a problem, number 1. And we're going to write out our P1, V1, T1, P2, V2, T2. And let's say we have 5.0 atm for our first pressure with a 2.0 liters for our volume and negative 40 degrees Celsius for our first temperature. And then P2 will be our X. We will have 6 liters for our volume and 54 degrees Celsius on our last temperature. Now we have to go and add 273 to each temperature to make it to Kelvin, and that is standard temperature in Kelvin. So the first temperature will equal out to 233 Kelvin, and the last one will equal out to 327 Kelvin. After that, then we can start plugging in them into the formula. So we'll put the 5.0 atm times the 2 liters equal to X times 6 liters. And we will put them both over their temperatures. So the first one will be 233 Kelvin, and the second one will be 327 Kelvin. Now you will take the top 2 numbers and you are going to want to multiply them together. So when you multiply 5.0 and 2 liters, you get 10, and that is over 233. And then the other side, you will get 6x over 327. Then you're going to cross multiply. And when you get that, you'll get 1,398x equals 3,270. Then you're going to take the 1,398 and divide them on both sides. So the first side will cancel out, and you will get x equals 2.34 atm. And that is your answer. And so now we are on to our second problem. And it says a 5.0 liter air sample has a pressure of 120 kPa at negative 50 degrees Celsius. What will be the volume of air at STP? So I'm going to start out by writing the P1, V1, T1, P2, V2, T2. And we're going to plug them in. So our first pressure is the 120 kPa. The first volume is going to be the 5.0 liters. And the first temperature is at negative 50 degrees Celsius. Now, in the problem, it says what will be the volume of air at STP. So our pressure and temperature will be at STP, which is 101.3 kPa for our pressure and 273 Kelvin for our temperature. And then our volume will be the X. Then we're going to take our first temperature and change it into Kelvin by adding the 273, which equals out to be 223 Kelvin. Now we're going to plug them into our original formula. So you will get 120 kPa times 5.0 liters over 223 Kelvin equal to 101.3 kPa times X all over 273 Kelvin. Then again, you're going to take the top two and you're going to multiply them on both sides. So then you're going to get 600 over 223 is equal to 101.3x over 273. Then you're going to cross multiply again, and you will get 22589.9x equal to 163,800. And then you're going to divide by the 22589.9 on both sides. So the first side will cancel out. And then you're left with x equals 7.3 liters. And that is your answer on number 2.